Hi, welcome back. The problem today is about a typical radical equation which x is member of real numbers. Now let's get started. We have 2x squared minus 6x minus 1 equal to square root of 4x plus 5. From this equation, we have to put the condition of x that on the left-hand side should have greater or equal than 0, the same as the right-hand side. Then we would have x have to be satisfied this condition, x greater or equal than negative 5 over 4 or smaller than 3 minus square root of 11 over 2. Or x has to be greater than 3 plus square root of 11 over 2. So that is the domain of x. We have to find now let's move to the method to find the variable. For this, we have to think about the substitution. But how can we put the substitution? If we put a equal to square root of 4x plus 5, then we cannot connect the left-hand side with the right-hand side. If a square will be equal to 4x plus 5, then we have this system equation, and it is really difficult for us to solve this kind of system equation. So this is not the good way to put this kind of substitution variable. We have to find another form of the substitution variable. Then we select that a y plus b equal to square root of 4x plus 5. That is the form of the substitution we would have. We have to consider a and b based on the form we have below. We have a y square plus 2aby plus b square equal to 4x plus 5. And combine this with the equation. At the beginning, we will have the system equation like this. We have 2x squared minus 6x minus 1 equal to ay plus b. then we should have a squared over 2 equal to 2ab over negative 6 equal to b squared minus 5 over negative 1 minus b and equal to 4 over 8. Then, based on the series of this, we can find that the value of a should be 2 and b equal to negative 3. Then we replace it back to the substitution. We would have 2y minus 3 equal to square root of 4x plus 5. And we replace it to the asterisk system equation. We will have 2x squared minus 6x plus 2 equal to y, and for y squared minus 12y plus 4 equal to 4x. Then we simplify it. We will have x squared minus 3x plus 1 equal to y. For the second equation, we have y squared minus 3y plus 1 equal to x. You see that this is a very common form of the system equation. We can easily do so that by subtract the first equation with the second equation, and by this way we will have x squared minus 3x plus 1 equal to y, and the second would be the subtraction. This is x minus y and x plus y minus 2 equal to 0. Then we have two cases here. The first is x equal to y, and replace it back to the first equation. This would have x squared minus 4x plus 1 equal to 0. And from this equation, this is a quadratic equation, we can easily to find the root of this. We have x equal to 2 plus square root of 3, or x equal to 2 minus square root of 3. And when we compare these solutions to the condition at the beginning we have, then we only can select one of solution. This is 2 plus square root of 3. The other we cannot receive it. Similarly, for the case x equal x plus y minus 2 equal to 0, Then from the first equation, we would have x squared minus 2x minus 1 equal to 0 that also have two roots. And the same for the first one, we will check the roots of this equation to satisfy the condition at the beginning. Then we will see the second one and then we see the first one. Finally, we have two variable x that is the root of the equation, that is x equal to 2 plus square root of 3 or x equal to 1 minus square root of 2. So that is the final solution of this equation. The most important thing of the problem is about the way you put the substitution here and the way how you find the coefficient A and B. And I already showed you how to calculate the A and B values and then replace it back to the equation. Then we have this form. This is a very common form of the system equation. That's the reason I try to put the substitution like this way and find the value of A and B. Then you will find the root based on the quadratic equation. Then just check the condition to satisfy with the root value. Finally, you have the result of the problem. That's all. Thanks for watching. See you later. Bye.